This video is going to go through a gear train calculation. We need to calculate the speed of gear E if gear A is rotating at 675 revolutions per minute. First, we will write down each piece of information we were given. We know that the original driver gear, gear A, is rotating at 675 revolutions per minute. We are trying to find the speed of gear E, so we will use the lowercase letter n to represent gear E. Now we need to record which the driver gears are and which the driven gears are. Gear A is our first driver, so we will call this capital D1, and it has 45 teeth. Gear A drives gear B, so gear B is the first driven gear, and we will call this lowercase d1, and it has 80 teeth. Next, gear B drives gear C, so gear B is capital D2 at 80 teeth, and gear C is lowercase d2 with 25 teeth. Gear C and gear D are on the same shaft, so gear C does not drive gear D. Moving on, we see that gear D drives gear E, so gear D is the next driver gear, or capital D3, and it has 60 teeth. Gear E is lowercase d3, and it has 15 teeth. Now that we have each gear assigned to be either a driver, driven, or both, we need to look at our basic equation. Capital N times D1, D2, D3 is equal to lowercase n times D1, D2, D3. We are trying to solve for lowercase n, so we will use the working equation that n is equal to capital N multiplied by D1, D2, D3 divided by lowercase d1, d2, d3. Next, we can substitute in what we are given. This gives us 675 RPM multiplied by 45 multiplied by 80 multiplied by 60 divided by 80 multiplied by 35 multiplied by 15. After running this calculation, we see that gear E is rotating at 4,860 revolutions per minute. This concludes our gear train calculation.